So we're going to have a look at target number 5 here. Scarlett has a 7 by 11 by 13 block of wood in the shape of a rectangular prism. They paint all 6 external faces of the block of wood red. Then they cut the block into a whole number 1 by 1 by 1 unit cubes, such that all cuts are parallel to at least one face of the original block and none of the wood is left over. Among the unit cubes that have at least one painted face, what is the average number of painted faces per cube? Express your answer as a common fraction. Okay, first thought, there's a lot of words in this question. Why are there so many words? A key bit of it is this middle sentence is not that relevant. So basically, you've got this block of wood, 7 by 11 by 13, and then you cut it into 1 by 1 blocks in exactly the way that you would imagine doing that. And, the problem's being a bit more precise about it, but, we know what's going on. So one thing we could do is we could think about the blocks of wood that have painted faces. Some of them are going to have one painted face. Some of them will have 2 painted faces because they're on the edge of the block. Some of them will even have 3 because they're on the corner of the block. We could figure out how many of each and do some averaging. That'll work. That's not actually a terrible method, but it's a little bit faster to just think about how many painted faces there are, and then how many unit cubes that have at least one painted face, right? We're not averaging over all the unit cubes, just the ones that have at least one painted face. So, first thing we want to know is how many painted faces are there? How many 1 by 1 painted squares are there? And that's just the same as asking, what is the surface area of this prism? Because it gets chopped into 1 by 1 squares. All right, surface area of a prism. This prism has 6 sides. One of them is a 7 by 11. One of them is a 7 by 13. One of them is an 11 by 13. And then there's actually 2 of each of those because that's how prisms are. Their faces come in pairs. And that is 622. Use your calculator or take my word for it. So that's how many painted faces there are. At the start, they're all joined together, and then we cut it into blocks, and then they're all separated. Now, how many unit cubes have at least one painted face? I don't know. Well, I can tell you how many unit cubes there are, right? It's 7 times 11 times 13, because it gets chopped into 7 by 11 by 13 cubes. And that is 1001. Fun fact for you, it looks prime, but it's not prime. It's 7 times 11 times 13. But some of those have no painted faces. How many of them have no painted faces? Well, it's the ones that aren't on the top and aren't on the bottom. So instead of being a 7 by 11 by 13 cube, we're cutting off the top, we're cutting off the bottom, and now it's 5 by 9 by 11. So we cut off the top and the bottom, we cut off both sides, we cut off the front and the back, and then all those cubes in the interior are not painted, and that is 5 times 9 times 11, which is 45 times 11, 4 plus 5 is 9, so that's 495. So 495 of our 1001 cubes are not painted, as they have no painted faces, meaning that the other 506 1 by 1 by 1 unit cubes do have at least one painted face. So now we have everything we need to have the answer to this problem. We know the total number of painted faces, we know the total number of unit cubes that have at least one painted face, and if we want the average number of faces per cube, we just divide the faces by the cubes. And that is 622 divided by 506, which simplifies to 311 divided by 253. And let's see, 253, that's 23 times 11, right? Because 2 plus 3 is 5. 311 is not divisible by 11 and is not divisible by 23. So that fraction is in simplest form, even though the top is bigger than the bottom, that's fine. So that's the answer. That's the average number of painted faces per cube. And that's about what we should expect, right? It's about a little bit more than 1, but not as big as 2. And if you think about the cubes, most of them are going to have one painted face, but some of them will have more, so seems about right. Let's put it in the answer box.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.